Good morning, dear cadets. So today I am going to start K2Cr2O7, their physical properties. Okay, physical properties. Okay, so method of preparation, yesterday only I told you. Okay, so in method of preparation, that is most important. One method of preparation from K2Cr2O7 and one method from the KMnO4. Out of two, one will come, and you know that set system is there, both may come. So remember, be ready for the facing this question. One thing. Second one thing, yesterday I taught you why higher oxidation state is acidic and covalent, lower oxidation state is basic and ionic, isn't it? In NCERT book they have not given their explanation. Okay, remember this one. One more thing I would like to tell you, don't worry about the quality and authenticity of the matter. That is my baby, isn't it? I will read from one book. If I am not satisfied with that book, so I will go for the another book. I may check from the net also. You can also check from the net, because nowadays you are free. You are having ample opportunity to seek the answer from here and there. So there is no problem. But remember one thing. If your teacher should be the library, he should study, okay, and he should explain you. That is why the teachers have been kept in the school. And as far as concept is concerned, you can also go through so many books, but that will consume a lot of time. So what I want to tell you, as far as authenticity of the matter is concerned, fully rely on me. I may commit some small mistake like addition of one electron, I may add 2 electron or 1 electron, like that. So those are the minor mistake. You can also rectify that one, or you can send those queries to my WhatsApp group. Definitely sooner or later I will rectify it. One more request is there. Higher oxidation state is covalent. Okay, so just see, you can apply the Fajan rule also. In higher oxidation state, the cation will be small. So when cation is small, their polarizing power is very high. That will distort the electron cloud of an ion which is coming to react with that one. In that case also covalent character comes. I have seen some other book also. They have explained on the basis of Fajan rule also. So only covalent character. As far as acidic and basic character is concerned, the yesterday's explanation is fully correct. But covalent character and ionic character, especially for the covalent character, you can apply the rule of Fajan. Okay, so that is also one of the way to explain the things. Now in D block and F block and in P block, there are different kinds of concept. Okay, if you are not happy with one concept, you can apply another concept. But remember, don't experiment, because I have experimented, and with that experiment you have to also continue, isn't it? Answer should not be wrong, because whatever was possible, I have tried hard to simplify the things for you. But still one section fellow, they are getting a lot of difficulty. So you can't be held me fully responsible for that. Now it may be your problem also. Now basic should be clear, then only you will come to know what is the reality. Okay, now let us start the physical properties of K2Cr2O7. So the first one is the color. Okay, what is the color of K2Cr2O7? It is orange red crystalline substance. What is this one? Orange red crystalline substance. Solubility, soluble in hot water but moderately soluble in cold water. Okay, moderately soluble in cold water. Soluble in hot water but moderately soluble in cold water. That is the physical property. Okay, now chemical property. First one is action of heat. What is this one? K2Cr2O7, that is potassium dichromate. Okay, if you heat this one, then it will be converted into potassium chromate. Yesterday only I told you Cr2O4, Cr2O4 2 negative. This is chromite ion, okay, and CrO4 2 negative. This is chromate. What is this one? Chromate ion. Okay, and Cr2O7 2 negative. This is dichromate ion. Okay, dichromate ion, chromate ion, sorry, chromite ion and chromate ion. Remember this one. So just see here, potassium dichromate is upon heating getting converted into potassium chromate. Always remember, just develop this habit. Just below the name of, means below the formula of substance, you should write their chemical name. What is this one? This is potassium dichromate. Potassium dichromate. And what is this one? This is potassium chromate. Potassium chromate. This is chromic oxide. What is this one? Chromium oxide, green color. Okay. So what is the conclusion of this reaction? Upon heating, dichromate ion is getting converted into chromate ion. Okay. So the stability at higher, means at higher temperature, which is more stable? Chromate ion is more stable. And at low temperature, dichromate ion is more stable. This is the conclusion. Okay. Now reaction with the alkali. Now you are entering into very important mode. Action with alkali. This is alkali, KOH. Orange red, this is potassium dichromate. It is getting converted into potassium chromate. What is the color of this one? Yellow color. And what is the color of this one? Orange red color. Now you can write their ionic equation also. Just try to understand. Potassium, how many potassium are there in the reactant side? 4. This 2K, this 2K. Cancel out. This side also what is there? 4 are there. So now what is left here? Cr2O7 2 negative plus 2OH negative. So what is here? 2CrO4 2 negative plus H2O. Okay. So try to understand here. Writing ionic equation is not a problem. Okay. Just spectator ion, common ion which is present in reactant and product side, you can cancel out. Because now cancelling is also one of the art. Just see, this is between potassium and this ion. Ionic bond is there. So whosoever is forming ionic bond, that only should cancel out. You should not cancel out chromium and chromium here. Okay. Remember, only those ions are getting cancelled out whose oxidation state is similar in reactant as well as in product side. If there is a difference in the oxidation state, those should not be cancelled out. Like just see here. Here, chromium, just see. Here, this is and this one is the entirely different ion. CrO4, this is Cr2O7. So you can't cancel out. So now ionic form you have got this one. Okay. Now try to understand, there is one more issue. If this potassium chromate is treated with acid, just see, I will write here. Just see, K2CrO4, treat with H2SO4. So what is the product here? K2Cr2O7 you will get, plus K2SO4 you will get, plus H2O you will get. Okay. This is potassium chromate. What is this one? Potassium chromate. Okay. And this is potassium dichromate. Potassium dichromate. Okay. So just see, when you are treating potassium dichromate with alkali, then you are getting potassium chromate. But when potassium chromate is treated with acid, what is this one? H2SO4 is acid or not? So you are getting potassium dichromate. So what is the meaning of this one? What is the meaning of this one? In alkaline medium, this is getting converted into this one. So in alkaline medium, who is stable? In alkaline medium, chromate ion is stable. In acidic medium, dichromate ion is stable. It means there is a equilibrium between dichromate ion and chromate ion. Okay. Now what is that pH we should write? There is one particular pH in which dichromate and chromate ion is found in alkaline medium. In equilibrium. Okay. So just I will write. Now there also you can write in ionic form. How you will write that one in ionic form? Simple. Just see. See, I will write this side only. I am rubbing this one. Just see, with the continuation of same I wrote this one. When this one is treated with this one is treated with, here you write on treating K2CrO4 with acid, on treating K2CrO4 with acid. Okay, so you will get this one. Now you can write their ionic form. Potassium and potassium is cancelled out. So here what is there? CrO4 2 negative, plus here what is there? 2H positive. So here what is there? Cr2O7 2 negative. Now this potassium, please write here 2. So this potassium will also be cancelled out. Now H2, 2H positive. This sulfate is also cancelled out. Now plus H2O. So you have got ionic form or not? So it is easy to write the ionic form. Okay. Now what is the issue? That they are dichromate and chromate ion, they are found in the equilibrium. So that pH should be written. We'll write that equation also, don't worry. Actually they are at equilibrium exactly at pH 4. Exactly at pH 4. So in acidic medium Cr2O7 2 negative is stable. Just see, at pH 4 dichromate and chromate ion. What is the name of this one? Dichromate ion. Dichromate ion. What is this one? Chromate ion. Chromate ion. Dichromate ion and this is chromate ion. They are equilibrium at pH 4. Now suppose if pH is less than 4. pH is less than 4. Remember, generally in pH scale, what we consider 0 to 6.9 we consider acidic medium. pH 7 exactly we consider neutral, and beyond 7 we consider alkaline. But remember, generally if we are talking of acidic medium, so generally pH 4 is only, there is also range. This is for from this pH to this pH, strongly, very strong acid. From this pH to this pH, what is there? Strong acid. For this pH to this pH, weak acid. So the pH beyond 4 is considered to be the weakest acid. So generally what we consider, up to pH 4 only we consider very strong and strong acidic medium. So remember, just see, if pH is less than 4, then what would be there? Number of H positive ion will be more. Number of H positive ion will be more. And according to Le-Chatelier principle, equilibrium will be shifted in backward direction. Now why? See, if H positive ion will be more, H positive ion will be more. So just see, already here in the product side H positive ion is there. So H positive ion concentration will increase in the reactant side, and always remember, according to Le-Chatelier principle, what is there? Whatever change you imposed, now system will adjust itself in a such a way so that the imposed change can be undone. So you are increasing the concentration of H positive ion. So equilibrium will be shifted in backward direction. So now in acidic medium, who is stable? Cr2O7. Now suppose pH is greater than 4. pH is greater than 4 means you are heading towards the alkaline medium. So the number of OH positive ion will be more, and OH negative ion will combine with H positive, and they will form the water. So in this side, what would be there? The concentration of H positive ion will decrease, and equilibrium will be shifted in forward direction. Here I wrote backward, forward direction. Just a minute. Forward direction. Equilibrium will be shifted in forward direction. Okay, no problem. So what is the meaning of this one? Conclusion: in acidic medium Cr2O7 2 negative is stable. In basic medium CrO4 2 negative is stable. Correct or not? In acidic medium Cr2O7 is stable. In basic medium CrO4 2 negative is stable. Okay, that is the conclusion of this one. And now just see, in the laboratory you did the chromyl chloride test. In chromyl chloride test, what you did? You have added the potassium dichromate only. So we'll teach the chemistry of potassium dichromate. Now dear cadets, just see the chromyl chloride test. In chromyl chloride, what is chromyl chloride test? It is nothing but a confirmatory test for Cl negative ion. You did last year also, this one. Just see, in chromyl chloride test, what we are taking? We are taking one salt containing chloride ion. So NaCl is the best, that contain Cl negative ion, and then potassium dichromate and concentrate H2SO4. So what is there? K2Cr2O7 and concentrate H2SO4. So just see, K2Cr2 just solid form only you are adding to the test tube along with concentrate H2SO4, and you are heating this one test tube moderately. It should be heated. Then you will get NaHSO4, KHSO4 and CrO2Cl2. This is orange red vapor you will get. Orange red vapor of chromyl chloride. This is only CrO2Cl2. This is chromyl chloride gas. What is the name of this one? Chromyl chloride gas. Chromyl chloride gas. Now this chromyl chloride gas, when passed to the sodium hydroxide, what is this one? Sodium hydroxide. Okay, so this will be converted into, means their color, earlier what was this color? Orange red color. So it will be in yellow color. What it would be? Yellow color. Why it would be converted into yellow color? Due to the formation of Na2CrO4. Na2CrO4, sodium chromate. What is this one? Sodium chromate, NaCl and H2O. Okay, so this is the entire chemistry, means salt containing chloride ion. If it is added with the potassium dichromate with concentrate H2SO4, then orange red vapor will come out. When the same gas is supplied to sodium hydroxide, then what would be its color? Its color would be yellow. Okay, means it will be converted into yellow color. Why it will be converted? Means NaOH will be converted into yellow color due to the formation of sodium chromate. Okay, so this is the chemistry. Now in this way, almost the chemical property of K2Cr2O7 is over. The most important property is oxidizing character. So just see, acidified potassium dichromate is an oxidizing agent. Means alone K2Cr2O7 is not oxidizing agent. Acidified potassium dichromate is an oxidizing agent. This potassium dichromate, when treated with H2SO4, that is only, means mixture of K2Cr2O7 and H2SO4, that is known as acidified potassium dichromate. Actually it reacts and evolves 3 nascent oxygen. It evolves 3 nascent oxygen. Now just try to understand. Here oxidation state of chromium is +6, and what is the oxidation state of chromium is here? Here oxidation state of chromium is +3. So +6 to +3, it is undergoing reduction. Hence what is this one? Oxidizing agent. It is undergoing reduction, hence it is a oxidizing agent. Now just see, this nascent oxygen may oxidize I negative to I2, Fe2 positive to Fe3 positive, Sn2 positive to Sn4 positive, H2S2 2 sulfur 0. In H2S the oxidation state of sulfide ion is -2. In sulfur it is 0. Just see, in NCERT book they have given only ionic equation, and in the exam how they are asking, they will give the ionic equation. Reactant side they will give the ionic equation of this one. I will tell you how to form the ionic equation. And now in product side they will keep the blank and they will ask what will be the possible product there. So now I will tell you that one, and ultimately will tell you how to arrive at the ionic equation. It is very easy. And last year I taught you the balancing of one method only I taught. There was two method of balancing the redox reaction. That is the oxidation number method and ion electron method. I taught you ion electron method only, and that can also be done here also. Means the number of electron and all those. So just recall the previous knowledge and do this one, but how to write the ionic equation I will tell you. Now one by one I will take. First I will take the salt containing iodide ion, I negative ion. The next one is salt of iron, where oxidation state of iron is +2. Now salt of Sn, where oxidation state of Sn is +2. Similarly H2S. Okay. So just see dear cadet, first step would be common only, this is only. Now take first one there, I negative. I am taking here Ki, potassium iodide, plus H2SO4, because this is acidified potassium dichromate. What is this one? Acidified potassium K2Cr2O7. So the meaning is H2SO4. Now H2SO4 plus nascent oxygen. So what would be the product? One product here would be I2 plus K2SO4 plus H2O. Okay. In first step 3 oxygen is evolved. So to cancel out this one, just check this one other product is balanced or not. Here 2 Ki, yes. So potassium 2, I2 is balanced. Hydrogen is 2, hydrogen is 2. What is the total number of oxygen? Total 5 oxygen is there. This side also 5 oxygen is there. 4 and 5. So everything is balanced. But we have to cancel out this oxygen. So it should be multiplied with 3. Entire equation is multiplied with 3. So this 3 oxygen is cancelled out. Now here what is the product? K2Cr2O7 plus 4 H2SO4 plus 6 Ki. 6 Ki. Now just see. 3 and 4. What is the total number of H2SO4? 7 H2SO4 plus 3 to the 6 Ki. And what is the product here? Product is K2SO4 plus Cr2SO4 whole thrice plus 4 plus 3 plus here write I2 3 I2 plus 7 H2O. Okay. Now so ultimately I negative is now just see, you write there ionic form. We can write in ionic form also. How to write the ionic form I will tell. Potassium is 2, cancel out here. So what is left here? See, they are known as spectator ion. Ions which are present in both sides, they are known as spectator ion. Cr2O7 2 negative plus how many SO4 is there? 7 SO4 should be there. Okay. So just try to understand. 1 SO4 is cancelled out. This SO4 is also cancelled out. Okay. Now Cr2. Yes. Now this 3 SO4 is also cancelled out. Now 4. Now please balance the reaction. This side balancing problem is there. Now K total, this side how many K is there? 6 Ki. Just a minute, I will balance this one. So just to see what was the problem. There was one mistake. This is 3 K2SO4 plus 1 K2SO4. So total 4 K2SO4 is there. So now K ion is 6K and 2K cancelled out. Okay. Cr2O7. Now just see SO4, 4SO4, 3, 7SO4 cancelled out. What is left here? 14H positive is left here plus 6I negative. Now here what is the product now? Just see 2Cr3 positive plus 3I2 plus 7H2O. Just see, this is only ionic equation. What is this one? Ionic equation. What is this one? Ionic equation. Just see, everything is balanced. You can check. Now just see. Here, what is the oxidation state of chromium? Plus 6. So, plus 6 to plus 3. What is this one? This is undergoing reduction. Hence, what is this one? Oxidizing agent. Now, I is single negative, but I is here 0. So, I negative to I 0. What is this one? Oxidation. Oxidation. So, what is this one? This is, what is this one? This is undergoing oxidation. So, this is reducing agent and this is undergoing reduction, hence oxidizing agent. Over. Now you have got the ionic form also. So I negative is getting converted into, transformed into I2, means I is oxidized into I2 because of the nascent oxygen furnished by acidified potassium dichromate. Okay. Now just see. Second one, Fe2 positive. So just see, first step would be common. First step would be common. Just see here. You just take one salt which is containing Fe2 positive ion. Just see. Fe2SO4, FeSO4. Okay. Just see here. FeSO4 plus H2SO4. Now you may ask questions, sir, why you are taking H2SO4 in the second step? Just try to understand, we'll tell you. Number one thing is, this is acid, this has been taken in excess quantity. Okay. So H2SO4 plus nascent oxygen. Now what is the product here? Now Fe2 positive will be converted into Fe3 positive. So Fe2SO4 whole thrice. Now what are the else product here? Plus H2O. Now please balance the reaction. Just see. This is this one. Now H2O. See the oxygen. 4, 3 is 12. 12 oxygen is here. This side how many? 12, 13 oxygen. This side 8, 12, 13. Everything is balanced. You can check this one. Okay. Now add both reaction. Now here you have to multiply with 3 because you have to cancel out this oxygen. So this oxygen is cancelled out. Now what is the product here? K2Cr2O7 plus K2Cr2O7 plus 2FeSO4. Okay. So now 2 and 3. So it will become 6 FeSO4. 6 FeSO4. 3, 4 plus 7 H2SO4. Now here what is there? K2SO4 plus Cr2SO4 whole thrice plus 3Fe2SO4 whole thrice plus 7H2O plus 7H2O. Okay. Now just try to understand. Now everything is balanced. You can check here. 2 potassium, 6 iron, 6 iron. How many sulfate? 7 and 6. 13 sulfate should be there. Check here. 1 sulfate. 3, 4. Now 9. Yes, 13 sulfate is there. Now cancelled out spectator ion. 2 potassium is cancelled out. Now 6 sulfate and 7 sulfate. So this entire sulfate will be cancelled out. Now what is left now? Just check here. Here what is left now? This is Cr2O7, 2 negative plus 6 Fe2 positive, because here this is ferrous, plus 14 H positive. Now here what is there? 2 Cr3 positive plus 3 Fe2 3 positive. Correct? Oxidation state of iron is here plus 3 plus 7 H2O. This is balance also. Okay. Now check here. Everything is balance or not? 2 chromium, 2 chromium. Oxygen how many? 7 oxygen. 7 oxygen. 14 H positive. 14 H positive. Everything is balance. 3 tubes are 6 iron. Everything is balance. This is ionic equation. Means what is there? Fe2 positive is getting converted into Fe3 positive. So what is this one? Oxidation. So it is oxidation means what? Reducing agent. Here chromium is plus 6. It is getting converted into 3 positive. So what is this one? Reduction. Reduction. So what is this one? What is this one? Oxidizing agent. Now just try to understand. If same ionic form is split into 2 half cell, oxidation half cell and reduction half cell. Okay. So first we balance the oxidation half cell. Okay. So there are steps. Okay. Electron can also be added here. Same way you can balance the reduction half cell. When both half cells are balanced, then you can add that one. Okay. Since reaction is taking place in acidic medium, to balance the to balance the hydrogen ion, what should be added? To opposite side of that one, what should be added? Water molecules. To balance the H positive ion, H2O, water molecule should be added. Last year I taught you balancing of redox reaction by ion electron method. That can also be done. 6 electron will be added in case of chromium. First you split this one into 2 half cell. Like this one is, just see, this one and this one will be the reduction half cell. This one and this one will be the oxidation half cell. Correct or not? And one by one you balance. Then you will get the, for balancing of charge, electron and H positive ion, like that it is added. Okay. So this is also completed. Another one is, you can take the salt of SN2 positive. Same way you can write SN2 positive will be converted into SN4 positive. Similarly H2S will be converted into S0. So if you can do, then it is better. H2S. Okay, just a minute. Let me rub and clean the blackboard. Now, third one, sorry. You can take H2S. The first step is common. H2S plus nascent oxygen. So, what is the product here? H2O plus sulfur. H2O plus sulfur. Okay. So, now, here what should be there? Now it should also be, everything is balanced. Sulfur is 1, it should be multiplied with 3. So 3O is cancelled out. Now here what is the product here? K2Cr2O7 plus what is there? 3H2S plus what is there? 4H2SO4. Okay. Now what is the product here? K2SO4 plus Cr2SO4 whole thrice plus 3 plus 4 7H2O. Almost everywhere 7H2O has come, and almost everywhere second equation has been multiplied by 3, because in the first step nascent oxygen evolve was 3 only. So now just see, same way you can write the ionic equation also. Potassium is cancelled out. Now here what is there? Cr2O7 2 negative plus what is there? 6 positive. Just see, this H2S is there and H2SO4. So first you cancel out the 4 sulfate ion. So 3 sulfate ion, 4 sulfate ion is cancelled out now here. Now here just check here, what is left now? A 4 to the 8 somewhere, just see, 4 yes, only 4 H2SO4 is there somewhere. Balancing 4 3 7 correct hai, somewhere balancing is required. Let me balance it. So just see, there is no problem at all. Just see, H2S means 3 to the 6 H positive, correct? 3 to the S positive 6, yes, correct hai. So just see here, 3 H2S. So 4 to the 8 and 6, correct? So total number of H positive is here 14 H positive. 14 H positive, correct? Just see, 3 to the 6. Now try to understand here. Plus this is equal to Cr2 3 positive. So 2 Cr3 positive plus 7 H2O plus 3S. Okay. Now just see here. Now this should also be written now, S negative. So I will write here S negative, 2 negative. Okay. So 2 negative 2 0. What is this one? This is undergoing oxidation. This is undergoing oxidation. So since it is undergoing oxidation, hence what is this one? Reducing agent. Now here plus 6 and this is undergoing reduction, hence oxidizing agent. What is this one? Oxidizing agent. Okay, no problem at all. Everything is balanced. You can check this one. This is ionic form. Okay, don't get confused. Here 3 to the 6 plus 8. So total 14 H positive is there. 14 H positive ion is there. And this side 7 H2O. Now last one is SN. So just take here one salt of SN, and that can also be balanced. Just see here, SN, I am taking SnSO4. What is the oxidation state? Sulfur plus 2 plus here H2SO4 plus nascent oxygen. So here what is there? SN2SO4 whole thrice plus H2O plus H2O. Okay, so now just see, things are not balanced. Let us make this one 2. So 2SO4 3SO4 plus H2O plus H2O. So now 3, it should be multiplied with 3. Yes, so 3 is cancelled out. Here what is there? K2Cr2O7 plus what is there? Just see, 3 plus 4 7 H2SO4 plus 2SnSO4 2SN. So total 6 SnSO4, 3 to the 6. Okay, now what is this one? K2SO4 plus, actually this is SN2, 3 to the 6 divided by plus 3. Actually it should have been 4. So SN, just a minute, SN4 positive and SO4 2 negative. So crisscross this one. So SN2 SO4 whole 4. Now here SN2 whole 4 will come. Yes, because oxidation state of this one is 4 positive. SN2 SO4 whole 4. Yes. So now K2SO4. Now here SN2 SO4 whole 4 plus what is there? 7 H2O. 7 H2O. Now just see, 2 potassium. Okay. Now here what is there? Sulfate, 13 sulfate. 7 and 6 sulfate is cancelled out. Please balance the reaction. Here Sn is 2 only. How many sulfate is there? 2 sulfate, 3 sulfate. But this side how many sulfate is there? 4 sulfate. So there is a shortage of 1 sulfate. So it is better to make this one 2H2SO4. So here also it will be 2H2O. Now let us check the oxygen. 4 to the 8 and 8, 16, 17 oxygen. Now somewhere balancing problem is there. Let me balance this one first. Let us see. Don't worry about this one. Just check out this formula. Here, what is the ratio between SN and sulfate? 2:4. That can be written 1:2 also. So here, problem is here only. We can write this one SnSO4 whole twice. Okay. So now just see. Here sulfate, just check this one. There is no need to make this one 2. Single sulfate. Now no need to make this one 2. No need to make this one 2. Now it is already balanced. Just check. SN1. Everything is okay. Now take SnSO4. Single only. Correct? Now what should be there? H2SO4, 3 and 4. That is correct. SnSO4. Now here what is there? Take SnSO4 whole twice. How many? 3. Sn. Here 3. Plus 7H2O. So now just cancel out. 2K is cancelled out. Now this side how many Sn is there? 3Sn. So this side also 3Sn is there. 3Sn is there. No problem at all. Now just 3Sn is cancelled out. Now just see. Here Cr2O7 2 negative plus 14H positive plus SO4 3SO4 2 negative. So here what is there? This SO4 is also cancelled out. This SO4 total 10 SO4 should be there. 7 and 3 10. And this side how many Sn is there? This one 3 2s are 6 7. Yes, it is correct only. Cancel out this one, this sulfate also. So now what is left out now? Left out things are Sn will not cancel. Here you have to write Sn2 positive. This one Sn2 positive. This side also only sulfate. Here you write Sn only. Now how many Sn? 3 Sn. So now Sn2 positive, that is 3 only. Now here sulfate is cancelled out. This sulfate will not be here. Now as such it would be. Now plus 3 Sn 2 positive. Yes. Now balance this one. 3 Sn 4 positive plus 7 H2O. Yes. Check this one. Now one more product should be there, that is Cr2SO4. I did not write Cr2SO4. Plus here write Cr2SO4 whole thrice. This product. Okay. So now here write plus Cr3 positive or 3 positive. Yes, Sn4 positive. Yes, everything is balanced now. That is why here just see 3 2s are 6, 9, 10. This side also N7. Everything is balanced. This is ionic form. So Sn2 positive to Sn4 positive. What is this one? Oxidation. What is this one? Oxidation. Now here plus 6 to plus 3. What is this one? Reduction. So it is undergoing oxidation. Hence what is this one? Reducing agent. This is undergoing oxidation, hence oxidizing agent. Okay. This is undergoing reduction, hence oxidizing agent. This is undergoing oxidation, hence reducing agent. In this way your entire oxidizing reaction is completely completed. Ionic form also you can write. So I hope that you have got this one. 2Cr3 positive. Please write down here 2Cr3 positive. Now rest everything is balanced. Yes.